and best fitting lines. 2.6. Scatter plots and best fitting lines.
Do you have a hole punch away?
I do not. I meant to punch those. I guess I didn't punch your classes, but I punched geometry. I'm sorry. Okay, a scatter plot. Who knows what a scatter plot is? What?
The dots go all over the place.
Almost. Dots go all over the place. That's a good definition, I guess. Scatter plot is a graph of a set of data pairs x and y.
My bad, Tyler.
It's okay.
I won't interrupt next time.
Okay, so it's a set of data pairs x and y. If y tends to increase as x increases, then the data has a positive correlation. So a positive correlation is when y increases as x increases. Have you talked about positive and negative correlations before? Maybe. A negative correlation, what do you think a negative correlation is then?
Y decreases as x decreases.
Okay. Negative correlation. If y tends to decrease as x increases, not as it decreases, as it increases. So you're close, Isabel. Good effort. Y decreases as x increases. So x is always increasing in both positive and negative correlation. It depends what y is doing. So if y is going up, it's positive. If y is going down, it's negative. Okay? So then you get graphs that look like this. We're going to look at 3 different examples of things. You might have a graph, a scatter plot. Let's just make 3 scatter plots real quick. And let's say this one looks like this. Okay? And then let's say that this one looks like this. And then let's just say the last one's like this. Okay? I've got 3 different types of graphs there. 3 different types of scatter plots. What does this scatter plot appear to be doing? It appears to be getting larger or going up. So this we would consider as a positive correlation. What does this one seem to be doing right here? What's this one seem to be doing?
Decreasing.
Decreasing. So we'd be considering that one a negative correlation. Okay. And what does this scatter plot look like over here?
All over the place.
All over the place. So that would have no correlation. Okay. So these are going to be our 3 options. Positive correlation, negative correlation, no correlation. Okay. I can't find a pattern in this set of data. I can find a positive pattern in this set of data. I can find a negative pattern in this set of data. So like stores will use this a lot, right? Like Best Buy has thousands of stores, right? Within America or across the world or whatever. So they'll take a look at their overall data from all of those stores and see if their profits are going up, if they're going down, what the correlation is of where the locations are, things like that. Does that make sense? So companies use types of graphs like this to figure out things, to see if they're going bankrupt or if they're going to make it another year or not. Okay. So describe the correlation. Tonight you're going to have to look at some pictures and tell me what the correlation is. Let's say you have a graph that looks like this. And it's going to be 40, 80, 120, 160. And here we're going to go 40, 80, 120, 160, and we're going to go like this. Okay. And then we have another graph, and it goes 250, 350, 450, 550. And this one goes 40, 80, 120, 160. Okay? And then it has data that goes like this. Okay. What type of correlations are happening in those sets of data? Positive what? There are positive correlations in both?
No, that top one's positive.
Okay, so this top one is a positive correlation. The bottom one is a negative correlation. Okay? So these are pretty obvious right now. There's also another way we can figure out what correlations are happening. I was trying to say, we can also figure out through doing some type of like correlation coefficient. Okay, correlation coefficient. Correlation coefficient. And that is when, okay, correlation coefficient is denoted by R. So you need to know it's denoted by a lowercase r. Okay, by a lowercase r, it's denoted by r. It is a number from -1 to 1. Okay, that measures how well a line fits a set of data pairs. Measures how well a line fits a set of data pairs. Okay. If R is near 1, what do you think type of correlation it is? Positive, negative, or no correlation? Okay, so if it's near 1, okay, if R equals 1, then it's going to be closer to a positive. If R equals -1, it's going to be a negative, okay? And if R equals 0, okay, then it's going to be no correlation. So, no correlation, positive correlation, negative correlation. Okay. So we have to estimate what type of correlation there's going to be. We're going to have to estimate by looking at pictures, and it's kind of a guessing game at first until you get used to it, okay? So don't like stress about it, but okay, we're going to kind of guess. So what happens is they give us options where they'll give us graphs and they say, tell whether the correlation coefficient for the data is closest to -1, -0.5, 0, 0.5, or 1. So if I have a diagram that looks like this, it counts by 50s, 50, 100, 150, and the bottom counts by, I don't even know what, 2, 4, 6. Okay, and I have data points at 175-ish, 1, here, and then I have it at 2, so let's move these over a little bit. And then I have it at like here, and here, and then I have one around here, and I have one up here, and I have one here and here, and I have one here and here. They want to know, according to that scatter plot, okay, they they want to know what the correlation coefficient is. Is it -1, -0.5, 0, 0.5, or +1? What is it closer to? So if you look at that data, does any of it look like it could be in a line? Could you roughly make a line out of that data? That's what you're kind of looking for, okay? The scatter plot shows a clear but fairly weak line. So right here, I could kind of have a line going through that set of data, right? The data kind of flows into that thing. Is that line going up or down? Down. So what type of correlation would that be close to? A negative. Is it dead on a negative correlation of -1? No. So what would my correlation probably be more closer to? Like 0.5. So this is going to be closer to an R of -0.5. Do you see how this is kind of a guessing game at times? Okay, for right now until we learn how to do some other stuff. So the best estimate given is that this is a correlation of -0.5. Then they give us another scatter plot.
I'm confused. Where's the -0.5 from?
Because, see, when I draw a line through it, I kind of have most of the data on that line. Like, I can kind of say it's close to making a line there, okay? But it's not perfect, right? Like, not all the data is, like, right around this line, okay? It's falling, just a minute, Brady, it's falling, so I know that it's negative. So I'm going to choose -0.5 because it clearly has some data that fits a line. But it's not like a set of data that's just random. So it's not 0, but it's not -1 because it's not perfect. So I'm going to go with -5.5. Does that make sense? Okay. Brady, yes? Okay, good. Yes?
I'm stretching.
Okay. So that's how I kind of determine that. What type? Those were your options. -1, -0.5, 0.5, and 1. So you get -0.5 because that's the closest option that we have. Okay. Here is an example. I'm going to make 3 of these. 50, 100, 150, 2, 6. Okay, here's an example that goes like this. Okay. Can I fit a line somewhere on there? Does it look like any of that data would flow into a line? No. So what type of correlation would this be? 0. Because there would be no correlation. So that would be the closest one for that. Okay? And one that would be a positive would look something like this. Which we're going to do positive, but then you're going to tell me. So if I have data that looks like that, I can almost draw a line through this stuff, right? Like that. Would that be closer to 0.5 or closer to 1? 1, because that data is really close to that line. So the more congested the data is, the closer it's going to be to 1. Does that make sense? Okay? Or to -1. Okay? The further out it spreads, I'm going to have -0.5, 0.5, or 0. That's kind of backwards of thinking, I think, a little bit. So the further it spreads, the less likely it is to be close to 1 or -1. Okay? So you're going to have to look at graphs tonight and be able to figure out correlation off of that using -1, -0.5, 0, 0.5, and 1. Okay? The other part you're going to have to be able to do, we're not doing this whole lesson because some of it involves graphing calculators and we don't have those. Okay? So you're not doing all of it. So if you get to a problem tonight, if I accidentally assign you one that says use a graphing utility, just skip it and know that that's okay. Okay, so then the other thing that you have probably heard of is the best fitting line. Have you ever done something with the best fitting line? Okay, and approximating the best fitting line. Approximate the best fitting line. Okay, there are basically 4 steps to approximating the best fitting line. Number 1, okay, draw a scatter plot of the data. Do I need to go over how to draw a scatter plot, or do we know what a scatter plot is or how it looks? Okay, can you graph X and Y coordinates? Okay, then you can draw a scatter plot. Part 2 is sketch the line that appears to follow most closely to the trend given. So you're going to sketch a line kind of like I did right here with these green lines, right? I put them in, it's kind of close to the data, okay? Sketch the line that appears to follow most closely to the trend given by the data points. Okay, there should be about as many points above the line as below it is what you're looking for. So you're going to put a line. I put this line basically with as many points above and below it, okay? That's what you're looking to do. Part 3, choose 2 points on the line. Choose 2 points on the line that pass through the 2 points from step, choose 2 points on the line, estimate the coordinates of each point. So whatever points fall on that line that you created, you're going to estimate the coordinates of each point. If you have 2 that you could read perfectly, don't estimate, just grab those 2, okay? Make it easier on yourself. These points do not have to be original data points. When it says they don't have to be original data points, what that means is sometimes they give us data in decimals or in things and we just multiply it by 10 so that we can make it a whole number. So you can still use those whole numbers. You'll get the same solution. Does that make sense? Okay. Step 4 is then write an equation, which means if you have 2 points, what type of equation or what type of steps are you going to have to take to write an equation?
Slope formula.
Yeah, you're going to have to use point-slope formula, so you have to find slope first and then use point-slope formula. Okay, write an equation of the line that passes through the 2 points from step 3. And then this equation is a model for the data. So this whole breakdown is on page 115. If you need to go back and look at the rules to follow, it's in a blue box on page 115. Okay? And then under it, they give us a set of data about cars. The table shows the number Y in thousands of alternative fuel vehicles in use in the United States. X amount of years after 1997. Approximate the best fitting line for the data. So what you would do, I'm going to come back over here. So what you would do is this. If my data, it says, let's see here, 0 through 7. This is X, this is Y. So that's what it told me. 280, 295, 322, 395, 425, 471, and the last 2 are 511 and 548. Okay, so what you're going to do to figure out, it says approximate the best fitting line for the data. So I have to come up with an equation of this. So what I'm going to do is first draw a scatter plot of my data. Okay, you're going to draw a scatter plot of your data. 0, 1, 2, 3, 4, 5, 6, 7. I don't even know what you want to count by here. 50s, I guess. Okay. Yeah, but I like making it closer if I can, just because this only goes up to 548, so I prefer to count by the least amount as possible. So 0 is at 280, which would be someplace like here. And then these are 6, 7, so that's 0. So then 1 is at 295, 2 is at 322, 3 is at 395, 4, I'm trying to line these up, 4 is at 425, so halfway in between, 5 is at 471, 471-ish, 6 is at 511, oh, I need one more, don't I? 550. So 511-ish, and 7 is at almost 550. So there's my scatter plot. Okay, that was step 1. Step 2 then says, sketch a line that follows most closely to the trend. So my line is probably going to go like this. Okay, this is step 2. Step 3 then says, choose 2 points on the line. Estimate the coordinates of each point. I don't have to estimate the coordinates. I have the coordinates. Okay, so I'm going to choose this coordinate, and I'm going to choose one kind of in the middle, just so that it's kind of even. Doesn't matter which 2 you choose. You just choose 2. So step 3, I'm choosing 2 coordinates. I choose 0, 280, and I choose 395. Okie dokie. So choose 2 points on the line, estimate the coordinates. I have that. Step 4, write an equation of a line that passes through those points. So step 4, equation means I need to have a slope. My slope is rise over run, 395 minus 280 over 3 minus 0, which would give me something over 3. What's 295 minus 280? What? 115. And then divide it by 3 for me.
38.3.
Okay, 38.3. That's my slope. So now I use point slope form, and I'm going to choose one of those 2 points, right? So I'm going to just choose this one. Y minus 395 equals 38.3 times x minus 3. So y minus 395 equals 38.3x minus, what's 3 times 38.3? 14.9, right? Or 14.9. I add 395 to both sides, and I'm going to get y equals 38.3x, and I'm going to take that, and I get plus 280.1. There's an equation for that line. Okay? Will our equations be a little different than our neighbors? Yes, that's okay, because we might choose different points. They're going to be a little off because we're estimating everything, so no big deal. But that's how you do this. That's the end of this.